Hey, what's up guys, and welcome to another calculus video. And today we're going to be tackling related rates. There are 6 steps that I believe that will help you find success. The first one is to determine the given values. This will help you throughout and is very useful. The second step is to draw the problem. In drawing the problem, you can visualize the problem more easily and help with trying to find the value requested. Then you need to write the equation. Uh, from the drawn problem, you should be able to find what you need to write an equation that will find the related rates necessary. Then you need to derive the equation, find the derivative of the equation. When finding the derivative of the equation, this will allow you to, after the value is inserted, complete the equation and find your given value, your needed value. Step 5 is to find the sign of the rate of change. This is necessary as without finding the sign, you could get a totally incorrect answer as your sign is wrong. And finally, step 6, plug and chug. The first step in completing a related rate problem is to identify what it is looking for. This can be done by drawing out what the problem is looking for / giving you. Then, after drawing the problem, you can use it to help you write out the equation. Then derive the equation you made and make sure to find the correct sign for the rate of change. After this, you can plug in the known values and solve for the value requested by the answer. And then you're done. Okay, now we're going to be doing an example problem. I've marked down the given values to start the problem. From the problem, we can establish that it's most likely asking for a triangle. But first, let me draw it up. The boat being here, there's 8 meters over here from the dock, and 6 meters up. The dock is up here because it says the dock is 6 meters higher. This is the boat. From this, we can establish that this is most likely a problem using Pythagorean theorem. So x squared plus y squared would be equal to z squared. Using this, we can find that z would equal 10, as 64 plus 36 would equal 100, and 100 squared would equal 10. And the next step would be to differentiate the problem. This equation. So the derivative of each would be 2x dx dt plus 2y dy dt, and this would equal 2z dz dt. Next, we plug in the values that we know. Because dy dt is going to remain at 0 because it's at a constant height of 6, so the change in y, there is no change in y. We can cancel out this. For dz dt, it's given at dz dt being 3 meters per second. So we can input this value, and we know z to be 10. So it would be 20 times -3, because it's getting pulled in. Because it's being pulled in, it'd be -3 meters per second. We do not know dx dt, and we're trying to solve it, so we input the value that we know, so it's 16x dx dt, and 16 dx dt equaling to 20 times -3, which would equal -60 equal to dx dt times 60. Then the next step is just to simply solve for dx dt. So dx dt divided by 16 equals negative 60 divided by 16, which equals dx dt equals 15 over 4, negative 15 over 4. That is the amount of meters per second that the bolt is being drawn in.